Hello. In this installment of SwiftUI for the old school guy, I'm going to talk about a mindset change that I had to go through in order to make a good SwiftUI public API on a set of classes I was making. If that type of discussion interests you, I invite you to go on this journey with me. Thank you. We will see how SwiftUI's declarative language requires us to kind of turn our public API inside out. So to begin, we open up our example and we go to the Compositional Design tab, and we will see a very basic SwiftUI view that has a slider control, a radio button, and an actual analog gauge. And what we're going to do is kind of show several design steps on that gauge that I had to go through in order to create a truly configurable SwiftUI API. Let's start with what we're used to looking at. So if we see like a traditional UI framework, you would create a new UI button. You would then do a whole bunch of empirical steps to configure the UI button. And so it works. You got this thing out there in memory, but then we need to start adding stuff. And so we're like, okay, well, we can have a constructor with 100 parameters with default values. Then we can inconsistently make some new features properties, even if you don't want them to mutate. And what happens is these things get large. I mean, we've all seen the list of storyboard properties for an object. It's enormous. There we go. Same thing with the Android XML layout files. So that works, but there's several issues with that paradigm. First, we don't really adhere to the RAII principle very well, which means that after the new, you have a fully constructed object, valid object, and you don't have this multiple steps for construction. The other principle that becomes difficult to adhere to is the open-close principle. As new capabilities are added, we tend to break existing interfaces. And then the other thing I discovered, which was kind of the straw that broke the camel's back when I said, oh, I'm not doing this right. It's really arduous to bubble up every possible value or strategy to the public interface. So what we want to do is we want to flip that and make our insides our outsides. So let's say we have a simple analog gauge that we designed for a client. It's kind of what you're seeing over here. We have a Z stack, which layers views on top of each other. We do a circle, we fill it with the color blue, then we draw a line, which is our needle, and we rotate it to a specific degree and frame it all 200, 200. Great, that works. All those hard-coded values and strategies are inside of private implementation. But let's say the client says, I need to start adjusting those values. You're like, okay, I can bubble all of those out to the public interface. So we have an initializer with default values on those. The only one that you have to pass in is value, which is great. So now the client can come along in here and say, well, let's change our background color to, mint. I think that's a color. Give it a chance to compile. And boom, let's go back in. Yeah, now it's mint. Awesome. But then the client comes along and says, we really need to have a better looking needle than that. Well, okay. Well, do I create a needle style object? Do I add more parameters on the init? Do I add more setters? Well, you really can't do setters in SwiftUI because of the nice atomic declarative way of initializing the structures. Then as I'm working on the needle, they said, oh, and we forgot to say we need ticks going around the edge, and we need some indicators kind of in the middle to kind of describe state and so forth. I'm like, okay, this has now grown exponentially. This is the problem I was having when I was developing my SPJ, where's it? My SPJ gauge library. Was I started out with this. I'm like, okay, cool. I got a gauge that I can put in my IoT projects. I was like, well, I want some differences between a gauge for lights versus a gauge for motors. So I started to expose all of these things. And then I'm like, oh, but I actually kind of want a clock in there as well. And so I was like, none of these strategies are going to help me make the clock. So then I started to create my own version of of Uber Gauge View where the needle was exposed as a property, as a strategy with default values, and it just kept growing and growing and growing. And then I decided, okay, Uber Gauge View needs to be deleted. And that's when it really clicked. I'm like, wait, the whole point of Swift UI design is that you supply all the little component pieces, and then the you let the client piece it together as well, kind of like little Lego pieces. You give some instructions, some examples, and let them form their own composition. And I realized after I did that, my code shrunk on both in the library and outside because that Uber object required all kinds of parameters to turn things on and off and so forth. It was a mess. Then the first thing I did was, okay, what happens if I remove all of the customizations? I came up with my standard gauge. The only thing that you can change on this object on SBJ gauge.standard.standard view is the model. And the model defines the range and the current value, and that's it. We have a nice gray background. We have ticks going around. We have an indicator here for its current value and the needle. This is what standard view looks like. And if we start changing the value, it reacts to that value change. Very nice. But that's it. So I'm like, okay. So out of the box, they kind of get that for free. Nice. I'm like, okay. Well, how hard is it for them to build their own gauge out of these pieces? So then what I started to do was expose the pieces and parts, adding the public keyword to a lot of components that were not declared public, and I was able to throw this guy together fairly quickly using the parts. So then we have the inside out gauge view. Now I was able to piece this together fairly quickly. Now, of course, I know my own library, but in not many lines of code, we were able to do this monster. Okay, so we have our ticks, which are smiley faces. We have a different kind of needle. We have a kind of this yellow background here. We have an indicator and we have two indicators. And if we move this value around, it does a couple different things. First, the needle is stationary. It's the ticks that rotate, kind of like on a mechanical scale. And then the background is changing color dependent on the current value. So let's see how these composite parts are pieced together. Okay, so I created a new struct, called it an inside-out gauge view. I reused my standard model. In the library, model is a generic type based on protocols, but the standard model is really easy to just use. All right, so I recommend folks use the gauge geometry view, which gives you a geometry proxy and kind of sets up aspect ratio and the z-stack and so forth, but not required. Okay, so I supply a standard background view, which draws a circle with a color. Nice. And I have a function I'll show a little later called color for mood that looks at the first value of our model to derive its color. Then right on top of that, I have my indicators, which is I have a text that says inside out, And, so this is just straight SwiftUI, none of my code inside of text. And then I do have my default indicator, which will resize a label appropriately, given the width. And so this uses a layout that I provide that is kind of a little smart about laying out indicators in a radial fashion. But it's like, well, if there's only two, it puts them down here as opposed to starting at 0 and going around and having them next to each other. So it tries to be smart, but you don't need to use it. Then we draw a circle with a stroke, which is our outside. Once again, standard Swift UI. And then this is where some of the interesting stuff comes in. Now I have this thing called radial needles view, which will rotate a SwiftUI object, get a SwiftUI view given the current model. And for this needles view is I embed my radial ticks view, which will then given inside of our model ticks. So we have a struct called a tick, which kind of describes its increment and so forth. This will draw them around in a circle, and then the radial needles view will rotate it. Now I'm thinking of turning radial needle view into a view modifier, but that's version 1.2 stuff or whatever. And then we draw our tick given the face. And then we just draw a stationary clock seconds hand, which is something I created for my clock gauge. So you can mix and match these Lego pieces. What I want to reiterate here is that the mindset, and I had to keep pounding this in over and over and over again, is, okay, this is a great way to start out, but once you start doing this, of exposing all of your objects into what you think is the parent object, it's a very UIKit way of thinking, and it tends to create a lot of confusing code bloat, because as soon as I started adding more strategies or exposing more strategies in this public interface, it just grew, and I didn't need to do that. I just needed to say, here are the pieces and parts I supply to make your life easier if you want to make an analog gauge. Piece them together however you want. In fact, I didn't even think to put my radio tick view inside of a needles view until I started working on my examples. I'm like, I wonder what would happen. And it just worked. And then I realized, I'll expose a clockwise faults to make it turn counterclockwise, which was more intuitive. And that's it. I would like to go over some aspects of the support code of this presentation. The first one is Copilot wrote my emotion enum for me. This was amazing. I told Microsoft Copilot, hey, make me an enum, raw value string, case iterable with 11 cases of Unicode emoticons going from happy to sad. And it built it right there. And then I asked for, given two SwiftUI colors, make me a function that will blend the two colors given a value between 0 and 1. And it wrote this function. I have used Microsoft Copilot a lot, not to do design, because that's still way too nuanced for this type of AI, but to just say, this function could be written, I don't want to figure it out, let's just do it, and it wrote it. And it works. Then let's look at the compositional example view, which is this. We have our way of declaring mutable state for views. And then we have the scrub view. Now, I wrote this scrub view because I had some very specific needs for my Internet of Things applications. Like I wanted a large space over here where you could say just go max or just go min. I wanted colors on both sides. There's some other features that I wanted. So I wrote it, and it's been working great. But then I was talking to my wife about the user interface inside my applications, and she's like, you know, it would be nicer if for certain gauges, the split for the red and green didn't move with the slider, just so you know you're on this side versus this side. And she said, also for that one, we would kind of want a gradient, and there were a couple other suggestions she made. So I started adding construction time parameters, and this is the mess that it is right now. These are all parameters on Scrub View. How they interact is not very intuitive. There's actually more functionality I want to add to this thing, but I kind of drew a line in the sand. I'm like, I need to do the similar type of refactoring on Scrub View because this is already bad, and I was going to be adding more. So there will be a refactoring on Scrub View, but this is a good example of another UIKit mindset, kind of creating a bad SwiftUI view API. Then we have our radio buttons, which just draws a circle and text. So switch out our gauges. I hope you appreciated this video, and I'll see you next time.